Next question is, solve the equation 4x minus 1 modulus is equal to x minus 3 modulus. Again, this is the same question that we have to square. In order to remove the modulus sign, we have to square on both the sides. So let us quickly solve this solution. First part, that after squaring, I get this 4x minus 1 whole square, means I have removed the modulus sign. So this is x minus 3 whole square. 4x minus 1 is 16, x square minus 8x plus 1 is equal to x square plus 9 minus 6x. So combining the like terms, 15 x square minus 8 plus 6 is minus 2x and 1 minus 9 is minus 8 is equal to 0. Now again, you may use your calculator to find out the factors, means the roots of this, or you can factorize if it is factorizable. So the factors that I will get after multiplying 15 and minus 8 is minus 120, and minus 120 means I can get I think minus 12 and plus 10. Okay, so 15x square minus 12x plus 10x minus 8 is equal to 0. So this is 3x, I can take common. This is 5x minus 4 and plus taking 2 as a common factor, again I will get 5x minus 4. Okay, this is equal to 0. So I have 5x minus 4 into 3x plus 2 equal to 0. So there are two possible values of x. One is minus 2 over 3 and another is plus 4 upon 5. Okay, this is your first part. Second says, hence we have to solve this equation correct to 3 significant figures. So let me utilize this space. As you can notice here that 4 raised to power 5 y plus 1 is there, and here we have 4x minus 1. Because since it says hence, that means using the solution of first part, we have to solve this equation, right? Directly we cannot, we may solve directly, but if it says hence, that means some portion of initial first part, that portion has to be used, right? So 4 raised to power y plus 1, I can write this as 4 into 4 raised to power y. Okay, this is 4 times 4 raised to power, 4 raised to power y minus 1 modulus is equal to modulus of 4 raised to power y minus 3. Now if you compare this equation of the second part with the equation of first part, you can see that if I replace this x with 4 raised to power y, I can get the same equation. If I replace this with x, okay, this will become 4x minus 1 is equal to x minus 3 mod, right? And this we have solved. So whatever solutions you are obtaining for x in the first part, same solution you will get for the second part, but instead variable x is now replaced with 4 raised to power y, right? So basically I have two equations, two solutions for this 4 raised to power y. That 4 raised to power y will be equal to minus 2 by 3, or 4 raised to power y is equal to plus 4 by 5. Okay, this is first thing. Second thing, now we have to choose whether both the solutions are acceptable, or you can omit one solution. Of course, 4 raised to power y equal to minus 2 by 3, that is not allowed, because since 4 raised to power y is an exponential function, you cannot use a negative value, because exponential function cannot be equal to 0, right? They are always positive, right? So we say that this is rejected, right, as exponential functions are always positive. So I have only this solution. So now we have to find out the value of y, because it is asking to solve, means here in the second part basically variable is y, but that y was in exponential. So 4 to the power y is equal to 4 by 5, that means taking logarithm on both the sides, I can write this as y ln 4 is equal to ln 4 over 5. Please do not try to remove this ln 4 with this ln 4. First thing is that ln 4 upon 5 is ln 4 upon 5 whole 4 upon 5. It is not separate, that you are taking log of only 4 and 5 is in the denominator, right? And you cannot cancel this log with this log, right? I have told you this earlier, right? So solution of y is ln 4 over 5 upon ln 4. Okay, this is the solution. Fine. Let us move to, and it is asking to correct to 3 significant figures, means you can use your calculator and just find out whatever is the decimal equivalent of this ln 4 by 5. Okay. Next is find the set of values of x satisfying the inequality where a is a positive constant. Again, this is again you can say a modulus inequality. So I think there should not be any problem in this. Let us square this. I'm writing directly that x plus 2a whole square is equal to or greater than 9x minus a whole square. Right? Opening the brackets, this is x square plus 4ax plus 4a square is greater than 9x square minus 18ax plus 9a square. Okay, so far so good. Just opening the bracket and applying the formula of x minus a whole square. Now combining the like terms, I can transfer this x to other side. I will get 8 times x square. Then transferring this plus 4 to other side, I will get minus 22 ax and then plus 5 a square. This is less than 0 because I have transferred all the LHS in the RHS. Fine. Now 8 into 5 is 40 and 20 into 2, right, is again 40. So I will use 20 and 2 as the factors. So 8x square minus 20ax minus 2ax plus 5 a square is less than 0. Taking 4x outside as a common factor, this is 2x minus 5a, and minus a as a common factor, you will get 2x minus 5 times a less than 0. So I have two factors, linear factors. One is 4x minus a and second is 2x minus 5 times a. This is less than 0. Again, I have an equality which is less than 0 and coefficient of x in both the linear factors are positive. So both the condition are not satisfied. Condition is, for satisfying the condition, there is only one point, that the coefficient of x should be positive, and if it is positive, the roots or the solution will lie between the roots for less than 0, and for greater than 0, solution is outside the roots, right? So between the roots means I have the value of roots as, if I draw the number line, like this, this point is, or I should, let us say, this x will be 5a by 2 and one x will be a by 4. So this value is a by 4 and this value is 5a over 2. Now how come I know, without knowing the value of a, how can I say that a by 4 is less than 5a by 2? Because in the question it says that value of a is positive, okay, where a is a positive constant. So obviously 1 by 4 is less than 5 by 2 because this a is positive. Whatever is the value of a, of course it is greater than 1, and it is also not 1 but it is positive, right? So obviously 5a by 2 is greater than a by 4. So my solution will lie between the roots, okay? So x is lying between 5a over 2 and it is greater than a by 4. Okay, this is your final solution. Next, question number 8 says that It is given that twice of ln 4x minus 5 plus ln x plus 1 is equal to 3 ln 3. We have to show that this is a cubic equation equal to 0, means this expression must be equal to 0. This we have to show, right? So what you have to do is, from the given equation, you have to remove the logarithm. Okay, as you can see, there are x involved, but there is also logarithm involved in the original equation, so we have to remove this logarithm by using the properties. Second point is, if you are solving this, then you can see that log of something plus log of something are both on the left hand side, so these two logs has to be combined. If you need to combine these two log, that means you have to apply the property of log a plus log b, which is log ab, right? Two separate logs can be combined, but in order to do that, this 2 has to be removed, right? So there should not be any coefficient to this log. So I can transfer this 2 to 4x minus 5 whole square using the property of log, which is log x raised to power a is a log x, right? I hope you are getting this, what the properties I am saying. So my given question is twice of ln 4x minus 5 plus ln x plus 1 is equal to thrice of ln 3, right? So this is log of 4x minus 5 whole square plus log of x plus 1 is equal to log of 3 cube. Okay, transferring this 3 again to this 3. So log of a plus log of b is log of ab. So my value of a in this case is 4x minus 5 whole square. B value is x plus 1. Okay, inside the square brackets is equal to log of 3 cube is 27. Okay. Now quickly, I can remove these logarithm from both the sides. So I will get 4x minus 5 whole square. So let us square this. This is 16. Let me remove this. Yes. 16x square minus 5 into 4 is 20 into 2 is 40 minus 40x plus 25 times x plus 1 is equal to 27. I have removed logarithm from both the sides. Now multiply this with x factor, so you will get 16x cube plus 16x square, then minus 40x square minus 40x, and then 25x plus 25 is equal to 27. Okay. Now last step, after simplifying, I will get 16x cube. Number of factors for x square are minus 40 and plus 16. So you will get minus 24x square. Total factors for x are minus 15x. And then 25 minus 27 is 2. So minus 2 is equal to 0. I think this is the final expression that the question was asking. Yes, 16x cube minus 24x square minus 15x minus 2 is equal to 0. Right? Hence we have shown this. This is your first part. Second part says, by first using the factor theorem, factorize this 16x cube minus 24x square minus 15x minus 2 equal to 0. Right? So for that we need to find out what is the first, by using hit and trial method, what will be the first 0 of this. Then only we will be able to determine one factor. Okay. So if you put x equal to 1 in the given coordinate, in the given cubic equation, let us see whether it will satisfy the equation or not, right? So if you put, I'm doing this here, okay, if you put p of 1, you will get 16 minus 24 is minus 8, minus 8 minus 15 is minus, and again minus, so p of 1 is not equal to 0. Then go for minus 1. This is minus 16, minus 24 is minus 40, plus 15 is minus 25, minus 2 is again not equal to 0. Then go for 2, right? 16 into 2 cube is 8. 16 into 8 is 128, right? Minus 24 into 4. 24 into 4 is 96. Then minus 15 into 2 is minus 30 and minus 2. Let us see whether it is coming out to be 0. Yes, it is coming out because this is 128 and this is again 128 equal to 0. So I will say that x minus 2 is one linear factor. Okay. So second part here is that x minus 2 is one factor of px. Okay. So your px, which is 16x cube, or let me again write this, 16x cube minus 24 x square minus 15x minus 2. This I can write as x minus 2 multiplied by one quadratic factor, right? This we have done in, I think, question number 1 or 2 in this assignment only. Means the type of question, of course the question is different, but method is same. So you need total cubes for is 16. So I should multiply this by 16x square. First thing is this, right? So your leading coefficient should be 16. So I have to multiply this by 16x square. Then you go for the constant term. Constant here is minus 2 and you already have minus 2 here, right? And this constant, when multiplied by some constant of this quadratic function, you will get the final constant, minus 2. So if you need minus 2 in the final answer, minus 2 you already have, so you need to multiply this by just plus 1. Okay. Now count for total number of x square. How many you need? Here you have 16 and minus 2 is minus 32x square, right? Means if you multiply this minus 2 with 16, you will get a factor of x square, right? If I am going too fast, just listen it carefully, that I need total x square as minus 24. I will get x square first by multiplying this 16x square with this constant. Answer is minus 32, right? It is minus 24. That means you have to add some x square to this. How many you need? How many x square you need to add to minus 32? This you need to add to get minus 24. Answer is plus 8. So you have to add 8x square to this, right? Second factor of x square means this 8 will come when you multiply this x with this x, right? Whatever you are about to write in this. And how many you need? You need total 8x square. So plus 8x you will write here. Okay, let me remove this. Right, and this 15x will get automatically adjusted because this is 8x into minus 2 is minus 16x and x plus 1 is x. Minus 16 plus x is minus 15. Right, so this is your second factor, which is quadratic. And let me see whether these are factorizable. Yes, as you can see here that this is nothing but whole square of 4x plus 1. Okay, this is your px. Right, and in the third part it is asking to solve the equation. Solving the equation means px is equal to 0 we have to do, means this we have to put equal to 0. That means x minus 2 is equal to 0 or 4x plus 1 must be equal to 0. Okay, so I have x is equal to 2 or x as minus 1 by 4. Now please pay attention. Do not leave the answer here. In logarithm and exponential terms, as I told you earlier, you have to check whether both the solutions are acceptable. Of course, x is positive. There is nothing wrong in this. But please do check for x equal to 2 only by putting it in the original function, in the original expression, which was in the form of log. right? So x equal to 2, this is 4 into 2 is 8 minus 5, positive, this is positive and this is positive. So x equal to 2 is acceptable. Let us put minus, I think minus 1 by 4, yes. So if you put 2 ln of minus x by minus 1 by 4, this will become minus 1, minus 1 is minus 6. So log of something negative is not acceptable, right? So x equal to minus 1 by 4 is not acceptable. You will leave x equal to minus 4 and x equal to 2 is the only solution. So this is not allowed, or you can write just as rejected. So x equal to 2 only is the answer. Okay. So I think uh, I have completed the whole assignment for chapter number 1 and 2. I hope you like this video. Please like, share and subscribe my Telegram channel. I told you earlier also. And let us meet. I do hope that we will meet in the next video with some interesting topic. And we are about to start the new unit, which is integration. Okay. Till then, bye bye. Take care. See you soon.